Continuation to this chapter of atomic structure. So we are going to start with this video in which we are going to discuss about the explanation of the line spectrum of hydrogen. In previous video I have discussed about the Bohr's model. In this we are going to discuss about the explanation of the line spectrum of hydrogen and the drawbacks of the Bohr's postulates. So as we discussed in the last video that delta is equal to h nu, so nu is equal to there is a change in energy upon h, is that is Planck's constant, and RH we have discussed Rydberg's constant. So nu is the frequency of radiation emitted or absorbed. So what are the limitations? These are the points which you have to remember and make understand what are the limitations of failures of Bohr's model. First point, that it fails to account for the finer details, that is the doublet, that is too closely spaced line of the hydrogen atom spectrum observed. Second point is that this model is unable to explain the spectrum of atom other than the hydrogen. Bohr's theory was also unable to explain the splitting of spectral lines in the presence of magnetic effect, that is known as Zeeman effect or an electric field Stark effect. And the last point is that it could not explain the ability of atoms to form molecules by chemical bonds. Now moving on to the next, that is the quantum mechanical model of the atom. So there are two important developments which contributed significantly in the formulation of such a model. First is the dual behavior of the matter and the second one is Heisenberg Uncertainty Principle. बच्चों बहुत ही आराम से इस चीज़ को समझिएगा. These are the two very important concepts to understand the quantum mechanical model of atom. We all know delta E is equal to h nu. Nu क्या है यहाँ पे हमारे फ्रीक्वेंसी है, एंड द सेकंड दैट इज द डी ब्रॉगली कॉन्सेप्ट यहाँ पे हम लोग पढ़ेंगे. फर्स्ट पॉइंट इज नोइंग दैट द लाइट हैज़ अ पार्टिकल नेचर, जो मैंने ऑलरेडी आपको प्रीवियस वीडियो में डिस्कस किया था, दैट इज हैविंग अ पार्टिकल नेचर एज वेल एज वेव नेचर. सो इट्स बेसिकली यहाँ पे हम लोग पार्टिकल नेचर को डिस्कस करेंगे. सो नोइंग दैट द लाइट हैज़ अ पार्टिकल नेचर, इट सीम्स रीजनेबल to ask if the matter have a wave nature or not. So using Einstein and Planck's constant, de Broglie has shown lambda is equal to h upon mv, where m is the momentum, mv is a particle property, whereas lambda is a wave property. So de Broglie summarized the concept of wave and particles with noticeable effect if the objects are small. So energy and matter, here you can see their size of matters, particle property and the wave property. If there is a large macroscopic particle, it is having mainly particle property and no or unobservable wave property. If intermediate electrons are there, then there are some particle property and some wave property also. If the size of the matter is very small like a photon, then it is having few particle property and mainly wave property. So small photons generally have a wave property and intermediate electrons are having partial particle and partial wave property. Now talking about the uncertainty principle given by the Heisenberg, so it is impossible to determine simultaneously the exact position and the exact momentum of an electron. So delta x into delta p is equal to h upon 4 pi. So हमने p is equal to हमारा momentum होता है, that is mv, and that is greater than h upon 4 pi. So delta x is the uncertainty in the position and delta px is equal to uncertainty in momentum. So basically इसमें uncertainty principle में क्या बताया गया था कि it is impossible to determine, एक ही टाइम पे हम किसी भी पार्टिकल्स की पोजीशन और एग्जैक्ट मोमेंटम हम नहीं फाइंड आउट कर पाते हैं. पार्टिकल मतलब इलेक्ट्रॉन की बात कर रहे हैं. सो इट इज़ इम्पॉसिबल टू फाइंड द एग्जैक्ट पोजीशन एंड वेलोसिटी ऑफ एन इलेक्ट्रॉन. And what are the significance of uncertainty principles? Very important to understand. First point is that it rule out the existence of definite path or trajectories of electron and other similar particles. Then hence these are replaced by probability of finding the electron. तो बेसिकली इन्होंने फिक्स एग्जिस्टेंस ऑफ ट्रेजेक्टरी इलेक्ट्रॉन के बारे में नहीं कहा था. इन्होंने क्या बोला था, that there are certain possibilities that electrons might be present. And the second point is that the effect of Heisenberg uncertainty principle is significant only for motion of microscopic objects and it is negligible for that of macroscopic objects. So this is the reason where we are going to study about the Bohr's failure for the postulates, that it did not consider the wave character of electron. बोहर ने वेव करेक्टर ऑफ इलेक्ट्रॉन्स के बारे में कंसिडरेशन ही नहीं दी थी. एंड सेकंड इज दैट इट कॉन्ट्राडिक्ट द हाइजेनबर्ग अनसर्टेनिटी. जो हाइजेनबर्ग ने कॉन्सेप्ट दिया दैट देयर इज अ अनसर्टेनिटी and finding of electron, there is always a chances, but there is no fixed trajectory of electron. तो बोहर मॉडल ने इसको कॉन्ट्राडिक्ट किया था. बेसिकली uncertainty principle के बारे में. So now we are talking about the quantum mechanical model. So the branch of science that take into account the dual behavior of matter is called quantum mechanics, and the quantum mechanics was developed independently in 1926 by Werner Heisenberg and Erwin Schrödinger. These were the two scientists who were actually involved in the quantum mechanic model. First point is that the Schrödinger proposed an equation that contains both wave and particle terms. Schrödinger was the first scientist who proposed this equation, that is h into psi is equal to E into psi. E is energy and h is a mathematical operator called Hamiltonian. So solving this equation leads to a wave function. The wave function psi gives the shape of the electronic orbital. So basically psi से हमें क्या पता पड़ता है? It gives the shape of the electronical orbital. So shape really refers to the density of electronic charges. Basically where the electron density is high and where the electrons can be find out. So the square of the wave function gives the probability of finding the electron. That is psi square gives the idea of probability of finding the electrons. Here if we talk about quantum mechanics and the atomic orbital, solving the Schrödinger equation give rise to orbitals. So these orbitals provide the electron density distributed about the nucleus. So finding of electrons, maximum the probability and the major proportion of electron density find out through this. So wave quantum mechanics through which we can find out the probability and the atomic orbitals. It is solving the Schrödinger equation. So orbitals are described by the quantum numbers. First quantum number we are going to discuss. So orbitals in quantum numbers, Schrödinger equation requires three quantum number. That is the principal quantum number, which is same as Bohr's, that is your n, and n becomes larger, the atom becomes larger, and the electron is further from the nucleus. So it determines the size and energy of the orbital. N is equal to 1, 2, 3, 4. It represents the shells K, L, M, N. Next one is your azimuthal quantum number. This quantum number depends on the value of n, and the value of L begins at 0 and increases to 1. So we usually use letter for L, SPDF, for L is equal to 0, 1, 2, 3. So usually we refer to the SP, D and F orbital. It represents the shape of the orbitals. N is equal to 1, so L is equal to 0, so L is equal to n minus 1. So in this way we can find out the value of L. Now talking about the magnetic quantum number, that is M. So this quantum number depends on L. The magnetic quantum number has integral value between L plus L. Magnetic quantum number gives the 3D orientation of each orbital. So these are the points which you know, and you have to learn by your heart, that if the value of L is equal to 0, azimuthal quantum number की अगर value 0 होगी, so magnetic quantum number will also be 0. If the azimuthal quantum number is 1, so m is equal to plus 1 to minus 1, so plus 1, 0, minus 1. If L is equal to 2, then m1 is equal to plus 2 to minus 2. So in this way we can learn the values of magnetic quantum number. Three quantum numbers are not enough to explain the line spectra observed in the case of multi-electron atoms. So that is, some of the lines actually occur in the doublets, 2 lines closely spaced, triples, 3 lines closely spaced, etc. So this suggests the presence of few more energy levels that predicted the three quantum numbers. So in 1925, George Uhlenbeck and Samuel Goudsmit proposed the presence of fourth quantum number, which is known as electron spin quantum number, MS. So spin angular momentum of electron can have two orientation related to the chosen axis. So these two orientation are discussed or distinguished by the spin quantum numbers ms, which can take the value of plus half and minus half. These are also called as two spin state of electron and normally represented by the two arrow, that is spin up and spin down, as orbitals cannot hold more than the two electron and these electrons should have the opposite spin. Basically इसमें बच्चों two spins होते हैं, that is spin up and spin down, and this is also known as electron spin quantum number. Now here in this table you guys get the full explanation of principle, angular momentum, magnetic and spin, where you can see n is size and energy of the orbital. It describes the size and energy of the orbital. Where if we talk about the angular momentum, it defines the shape of the orbital. L की जो value होती है उससे हमें shape of the orbital के बारे में पता पड़ता है. Now if we talk about m1, that is your magnetic quantum number, it actually helps to find out the relative orientation of the orbital within the same L. And the last one is the spin quantum number, from whether the spin is plus upside or downside, that is the value is plus half or minus half. So now talking about the shape of the orbital or the name of orbital, that is SPDF. So S is sharp, P is principal, D is diffuse, and F is fundamental. Now you guys can see this is the table which actually shows the relationship among value of n, L and m through n is equal to 4. So here you can see if n is equal to 1, possible value of L, subshell designation, possible value of m1, number of orbitals in subshell and total number of orbitals in the shell. दिस इज बच्चों बहुत ही इंपॉर्टेंट है, इसका आप लोग स्नैपशॉट ले लीजिए और इसकी प्रैक्टिस कीजिए, बिकॉज दिस टेबल इज गोइंग टू बी वेरी हेल्पफुल फॉर solving the multiple choice question, as well as you guys can see the value of, you can find out the value of L, M, N through this table. So all the values given over it is very important. Okay, so through this you guys can learn the how to find out the value of principal quantum number, azimuthal quantum number, magnetic quantum number. This slide show the shape of the atomic orbital on plotting psi square against the radius r. The following graphs was obtained if we talk about 1s and 2s. So on both the cases, the probability of finding the electron decreases as we move away from the nucleus, but in 2s there is an increase in the electron density and then again it decreases. So the region where the probability of finding the electron is 0 are called nodes. जहाँ पे finding of electrons की probability 0 हो जाती है उसको हम nodes बोलते हैं. And nodes का calculation, that is equation given by n minus 1. Now we talk about the shape of the orbitals, which are represented by boundary surface diagram. So this is the representation of orbital, that is s orbital is circle. Now in the next video I am going to discuss about the p and d and f block f orbitals. उनका हमें different shapes के बारे में हम पढ़ेंगे बच्चों. For this is the complete video where you have seen principal, azimuthal and spin quantum numbers. I think you guys have lot of learning through this video, and please share this video to those who are actually looking for some good notes for the class 11th atomic structure. Thank you so much. Do like, share and subscribe my channel.